Hi and welcome to Inspirational STEM. My name is Harish. So today the problem set is about systems of equations. All right, let's go ahead and get started. So if you get a problem like the one we have, the very first one, and it says whether the ordered pair is a solution to the system of equations. So pretty much all that we're asking here is, so we have -1 and 1 as the x and the y value. So is that a solution to the system of equations that we have here? So let's go ahead and substitute then. So very first equation we have 3 times -1 minus 1 should equal 4. Okay, so how much is that? That's -3 minus 1 should equal 4. So that's -4 equals 4. So that is not true. All right, so we know already that this ordered pair -1, 1 is not. So we can just go ahead and say it's not a solution. But if you want, just go ahead and check the second one as well. You can do that. So -1 plus 4 times 1 is 4 equals -3. So that is also not true. So okay, so this ordered pair is not a solution, okay, to the system of equations that we have here. All right, very good. Let's move on to the next problem. So for the next problem, we have to use substitution to solve the system of equations. All right, so let's go ahead and see how we can solve this. So we have the first equation. So let's go ahead and solve that for y. So we have 10x plus 5y equals -5. So I'm going to subtract 10x from both sides, or just move 10x to the other side. So what that's going to give me is 5y equals -10x minus 5. So then we want to isolate the y. So we're going to divide the whole equation by 5. So I'm going to go ahead and do that. 5 all over. So that's going to give me 5's get cancelled off. Y equals, now 5 goes into -10 twice and 5 goes into -5 once. So we have y equals -2x minus 1. All right, so that is the one we are going to use to substitute into our second equation, which is 3x minus 2y equals -12. So let's go ahead and do that. So we have 3x minus 2 times y value is minus 2x minus 1. That's the one we're going to go ahead and substitute. So minus 2x minus 1 equals -12. So that gives us 3x. So I'm going to distribute that, -2. So we get negative times minus 2x is positive 4x, and then -2 times -1 is positive 2 equals -12. So let's go ahead and combine the terms now. So 3x plus 4x is 7x. And then I can go ahead and take my positive 2 and move it to the other side. So 7x equals, so -12 minus 2, that's -14. Okay, so let's go ahead and divide both sides by 7 to isolate the x. So that gives us x equals -2. Okay, so that's one of our first variable values. X equals -2. So go ahead and substitute that into any one of these equations. So let's go ahead and substitute that into 10x. So 10 times -2 plus 5 times y equals -5. So that's -20. -20 plus 5y equals -5. So we go ahead and take the -20 to the other side. So 5y equals, that becomes positive 20. So positive 20 minus 5 is 15. So divide both sides by 5, and that gives us 3. Y equals 3. So the ordered pair that we have received as our answer is x equals -2 and y equals 3. So this is our final answer. This ordered pair is, so answer is going to be -2, 3. Now you can, if you want, you can go ahead and check your answer really quick to see if that is indeed correct. So you can go ahead and substitute that into, let's say, into the second equation. So -2 times 3 is -6. So let's go ahead and do that. So -2 times 3 is -6, minus 2 times y is 3. So that should give us -12. Okay, and indeed it does. -6 minus 6 is -12. So that is correct. So this answer is correct. All right. Okay, very good. Let's move on and see. So we have another problem of the same sort where we have to substitute the one of the variables. So let's go ahead and try to do that again. So let's see. So let's solve for x in this case in the second equation. Really doesn't matter which equation you use to solve for variable. You're just going to use that variable value and substitute into the other equation. Okay. All right. So we have 4x plus 8y equals 8. So what I'm going to do is I'm going to take the 8y to the other side. So that gives me 4x equals -8y plus 8. I'm going to divide all of both sides by 4. When I do that, I isolate the x. So we can get an x value. 4 goes into -8 -2 times. 4 goes into 8 2 times. So we have x. So I'm just going to write that here. X equals -2y plus 2. Okay, that's our x value. All right. So I'm going to go ahead and take that x value and substitute into the equation we haven't used yet, which is the first equation. So let's go ahead and do that. 5 times the first equation is the one I'm going to use. 5 times I'm going to use the x value we just generated from the second equation. Okay. So 5 times -2y plus 2 plus 6y equals 14. So that's what we have received so far. So I'm going to go ahead and distribute that now. 5 goes into -2y -10y times. 5 goes into 2 plus 10 times. 5 times 2 is 10 plus 6y equals 14. Okay, so let's go ahead and combine the like terms now. So -10y and plus 6y gives me -4y. And then I have plus 10 equals 14. Now you can take the variable to the other side and bring the numbers to this side. It doesn't matter what you do. In this case, let's just go ahead and take our 10 to the other side. So we have -4y equals -10, -10 plus 14, which gives us +4. Okay, so -4y equals 4, and then divide both sides by -4. So that gives us y equals -1. So y equals -1. Okay, so that's one of our first variable answers we have. And now let's go ahead and take that y equals -1 and substitute in any one of the equations. We can even substitute that into the simplified answer of x we have received here. Let's go ahead and do that. So we said when we simplified the x was, we got x equals -2y plus 2 up here. And then, so I'm just going to substitute the y value. So x then becomes -2 times -1 plus 2. So negative, that's +2 plus 2. So I'm getting a x value of 4 now. Okay, and we already received a y value of -1. So our ordered pair for our answer then is going to be 4, -1. Always remember x is written first and then y after. Now you can take this and you can check that, make sure that is correct. Let's go ahead and do that. Let's go ahead and take our second equation and see if that works. 4x plus 8y plus 8y is 8. So I'm going to substitute that. X is 4. 4 times 4 is 16, plus 8 times -1 is -8. So 16 minus 8 equals 8. That is indeed correct. So we are going to say this ordered pair 4, -1 is indeed a solution to the system of equations. Okay, so what is the meaning of that? Well, graphically, that means that when you graph them together, then they will intersect in that one point. I'm just going to show you just a rough graph here. This is not representative of these equations, of course, but then when you graph a system of equations that has one solution, you will see that they will intersect each other at one spot, and that one point is the ordered pair, the answer for that system of equations. Of course, not this particular one, but you get the idea. So that is the answer to that. All right, let's move on to the next problem. So it says, for the following exercises, use addition to solve the system of equations. I would also like to mention that all of these problems are from the OpenStax algebra book, which is a wonderful resource. If you wanted to go ahead and check it, it's open source books, and they're really good. Okay, so let's go ahead and see how to use addition to solve the system of equations. All right, so we have a 3x and we have a 9x. So we know immediately that we can go ahead and multiply the first equation with a -3 so that we can cancel the x. Okay, so I'm just going to go ahead and do that. I'm going to take the first equation and multiply that with -3. Okay, what is that going to give us? That's going to give us -3 times 3x is -9x, and -3 times 4y is -12y, and then remember we have to multiply all of them, equals -3 times 2 is -6. Okay, very good. So I'm going to write, that's my first equation, and I'm going to write my second equation right below that to add it. So second equation is 9x plus 12y equals 3. So the way this addition works, I'm just going to draw a line like this, and then I'm going to go ahead and add them together. -9x plus 9x is going to cancel. That's going to be a 0. And then plus 12y minus 12y is also going to cancel. That's going to be a 0 on the left hand side. So on the right hand side, we have -6 plus 3. That gives me -3. So this is absolutely not possible for 0 to ever be equal to -3 logically. So we say that is not possible. So there is no solution for this system of equations. Okay, so what is the meaning of that? Well, that means graphically that these are not going to intersect at any given point. So remember, there are 3 scenarios. Number 1 scenario, the first is what we already talked about. When you have a two lines, each representing an equation, and they intersect at some point, that means there's one solution to that. Okay, the second, of course, is when you have 2 graphs that are absolutely identical, and they coincide, and they are basically form one line. That means they are identical to each other, and the answer to that is there are infinite number of solutions, the answers to that, because those both graphs are essentially coinciding. They are the same graph, they lie on the same line, so they are infinitely number of solutions. And third one, of course, is when they do not coincide at all. So they are parallel lines. Okay, they are parallel lines, and they do not intersect. They never will intersect, and though that's when you have no solutions. Okay, so these are the 3 different scenarios that are possible with this system of equations, at least for linear equations. Okay, all right, very good. Let's move on to our next problem. It is a word problem. All right, well, for those of us who do not like word problems, unfortunately we're gonna have to do some of these, and let's see if what we can do with this. A factory has a cost of production. So this is given an equation is given. Cx is 150x plus 15,000, and the revenue function R of x is 200x. Okay, very good. So both of them are a function of x. What is the break-even point? Remember, break-even means when cost equals revenue generated, right? Revenue generated. So if it's less, then it's a loss. If the revenue generated is more than the cost of the production, then there is a profit, right? So let's go ahead and set these equations equal to each other in that case and see what happens. So we have 150x plus 15,000 equals, so I'm going to set it equal to the next equation, which is 200x. So all we did was we're trying to find the break-even point where cost equals revenue. So we are going to set both of these equations equal to each other. Okay, very good. Now what I'm going to do is I'm going to move 150x to the other side because it's a smaller variable coefficient, or I can subtract 150x from both sides. That is both the same thing. Either you move it or you subtract it. So left hand side 150x is gone. So on the right hand side we have remaining 50x. Okay, 200 minus 150 is 50x, and on the left hand we have 15,000. All right, so now I'm going to go ahead and isolate the x. So divide both sides by 50. So 50. So 50 gets cancelled on the right hand side. On the left hand side we have the zeros. 1 0 gets cancelled, and then the 5 goes into 15 3 times. And then there are 2 more zeros, of course, so 300. So x is 300. So we're not done yet because we want to find the value of y as well. Okay, or rather for x equals, there's no y actually, but for x equals 300, what is the revenue? So that's what we want to find out. So we already got x equals 300, and the revenue is 200. R of x is 200 times 300, so which is 6. 3 times 2 is 6, and then you have 4 zeros. Okay, so that is 60,000. So that is the point at x equals a production of x equals 300 units of something, and the revenue generated is 60,000. That is when you have the cost equals the revenue generated. Also the cost is also 60,000, obviously, because when you take 300, substitute that into the first equation, you are going to get 45,000 plus 15,000, which is equal to 60,000. All right, so that is our answer. And so not too bad. When you get a problem like this, just set them equal to each other so that you can find the break-even point. Okay, all right, very good. Moving right along, now we have slightly different kinds of problems to take a look at. So the very first slightly different kind of problem we have here is to solve the system of nonlinear equations. So how is that going to work? Well, let's take a look. Well, we can try to substitute that, or we can just also look at it and see intuitively, graphically. We want to find out what is the meaning of these equations as well, and that would be wonderful if we can understand that as well. But if, let's say, we did not know what they meant graphically, then let's just go ahead and substitute and see what happens. That has worked for us so far, so maybe it will work for us as well. So we have nicely a y equals x minus 8. I'm going to go ahead and substitute the second equation into the first one and see what happens. Well, we have x squared plus y is x minus 8. So I'm going to substitute that now. X minus 8 whole squared equals 16. Okay, very good. So let's go ahead and try to simplify this a little bit further. X squared plus, no, x minus 8 whole squared is simply something that is x minus 8 times x minus 8. You can distribute and get the answer, or you can do a perfect square trinomial, which is a minus b whole squared is a squared minus 2ab plus b squared. So either way is fine. Let's go ahead and do the second way here. So x squared minus 2 times a times b. A term is the x and the b term is 8 in this case. So 2 times a is x and 8 is b. So 16 minus 16x plus b squared. B squared is 64. And if you're not comfortable with this, you can just go ahead and multiply these and you'll get the same answer. Okay, so distribution, this is the FOIL first, last, and so on and so forth. FOIL, first, outside, inside, and last. Those are of the 4 terms. So the FOIL method, but you can do either. Now equals 16. So I'm going to go ahead and quickly combine the like terms here and see what happens. X squared plus x squared is 2x squared. And then we have, so I'm going to try to bring everything to one side, minus 16x, and then 64 minus 16. So that's going to be minus 16. I'm going to bring that to the left hand side. Okay, so that's 64 minus 10 is 54, minus 6 is 48. So plus 48 equals 0. So we want to have to solve this in order to get our value of our x. So let's divide everything. When you see quadratic equation like this where it can be greatest common factored out, GCF can be removed. So let's go ahead and remove that, divide everything by 2 really quickly, see what we get. So we get x squared minus 8x plus 24. So I'm going to write that on the left here, x squared minus 8x plus 24 equals 0. Now, is there a solution to this? Perhaps, but let's see if we can solve it. So if you do the m and m plus n method, so I got my 2 parentheses happening here. I put my x values here, x and x, so you can multiply to x squared. So I need two numbers that multiply to 24. M times n is 24, and m plus n equals negative 8. Now 24 factored can give, if you don't know how to do that, try to do a factor tree. 2 times 12, 2 times 6, 2 times 3. Now we have 4 times 6, and very quickly I can see that this is 8 and 3. So this is not happening. I mean, it's hard to find two numbers that are multiplied to 24 and add up to negative 8. So something is wrong, is problematic here. So let's go ahead, and when I have a problem, when I'm stuck with factoring and I'm running short of time, I just use the quadratic formula to see if this is even feasible or not. So remember, minus b plus minus square root of b squared minus 4ac divided by 2a is a quadratic formula, and the a, b, c's are the coefficients of the quadratic equation. So here the coefficient, so here if you remember, if you can see, a is 1, there's a coefficient of x, b is negative 8, the coefficient of the middle term, and then 24 is c. So let's go ahead and substitute that really quickly. So minus 8, that's positive 8, plus minus square root of b squared is negative 8 squared is 64, minus 4 times a is 1 and c is 24. So I can already clearly see what the problem is here. So the problem is that this 4 times 24 is negative 96. That's already bigger than the 64. So that's going to give me 8 plus minus square root of negative, that's 96, 64, 32, negative 32 divided by 2. So that's a negative number in a square root. So there's going to be no real solutions out here. So clearly, after all this work, we realized that this is not going to work out. There are no solutions here, probably, most likely. So no solutions. But here's the thing. I think no solutions because we are unable to find any real solutions. But also, if you can look at it graphically, then if you know what these graphs mean, then you can come to a resolution much quicker. And let me show you how to do that really quickly. So x squared plus x, so the first x squared plus y squared is 16 is the equation of a circle. How do you know that? Because the coefficients are the same, 1, and it's in the form of a circle. So the circle formula is x minus h squared plus y minus k squared equals r squared. So I'm going to go ahead and draw my circle out here then. So the circle is centered at the origin, because we know that here, if you go to the first equation, x squared plus y squared, there's no h and k term, so they'll be centered in this at the origin right there. And then the radius is 4. So I'm just going to go ahead and draw a circle, a rough sketch, just to show you what we are up against out here. And so I'm just going to draw a rough sketch of this circle right here. Okay, very good. Now let's go ahead and draw the y equals x minus 8 really quickly. Hopefully we are able to accomplish that here. So if x is 0, y is negative 8. So that creates a problem already for me. We see the x-intercept is kind of on the y is negative 8, so it's kind of beyond this circle. Let me just go ahead and bring this up a little like that. Okay, so basically, and then if I say x is 1, then y is negative 7. So we are getting a line that's essentially going past the circle. Okay, going past the circle. So when you actually, I'm sorry, there's no room here, but when you actually plot it, you will see that y equals x minus 8 is actually beyond the circle, because you have the negative 7, negative 8 is the y-intercept, and then when x is 1, then 1 minus 8 is negative 7. So 1, negative 7 is our second point. So this line is beyond this circle, which has a radius of 4. Okay, so that means there are no solutions. So if you're able to do that graphically really quickly, then you can catch this problem and say at an early stage of having to do all this work and say it has no solutions. Okay, so that's our resolution for this problem. All right, moving on. So no solutions. That's our answer to the problem. All right, very good. If you have any questions, please leave them in the comment below, and I'd be happy to answer them. So let's move on to the next problem here, and let's see what this gives us. So, I mean, I could try to substitute, but since I have found this other method where I can basically see very quickly graphically if it makes sense or not, let's just go ahead and do that now. Okay, so the first equation, we can be able to analyze the circle stuff a little bit better now. So remember, the generalized equation of a circle, the equation of a circle is given by x minus h squared plus y minus k squared equals radius squared. So h and k, where hk represent the center of the circle. Okay, center. And also you know that this is not a hyperbola, or it's not ellipse, etc., because you see the coefficients are the same for the x squared and y squared. So that's a clue that we are receiving here. Okay, so let's go ahead and see again. I'm just going to try to put my graphing drawing skills to a test here. Perhaps next time I should have a graphing paper out here that will make things much more easy for us. But please bear with me. Let's see what we get here. So remember, we said no h and k term because x squared and y squared is by itself. For this equation, x squared plus y squared equals 4. So 4 can be rewritten or 2 squared. So radius is 2 because r squared. So let's just go ahead and do that then. So I'm just going to do a quick circle here with our radius of 2. So that gives us a circle of this sort. My circle drawing skills not the best today. Okay, so that's our circle, and it's centered at the origin. Of course, we said okay, wonderful. Now let's go ahead and take a look at the next equation and see what we can do that graphically with that. So the next equation is, let's go, so is y equals minus x squared plus 3. So let's move, oh, I'm sorry. It's not that, it's y minus x squared equals 3. Okay, so let's go ahead and move the minus x squared to the other side, and what that gives me is y equals x squared plus 3. Okay, very good. So we know what y equals x squared looks like. So let me just quickly draw that here. It's the parent quadratic function graph, which goes through the origin and is a parabola, rises upwards, as you probably remember, from the origin 0, 0. Now plus 3 is just a translation, moves it 3 units upward. So 3 units, so if you look here on our graph where the circle is, so then let me go ahead and see if I can select another color here. Okay, so plus 3, so it has gone up beyond these 2 units, the radius of the circle that we said. So the plus 3, so the parabola is now opening upward from this point y, this 3 point. Okay, so it's a normal parabola y equals x squared, only that it's beyond the circle. Okay, so do you see that, how that is working? Because we have a translation of 3 units upward from the parent graph y equals x squared. So it's going up, so it's past the circle. So again, without having to do any substitution or anything, any sort, we see these graphs actually never coincide. So the answer is no solutions. So that is our final answer. Okay. I hope that, I think this was a nice example where previously we tried with substitution, but again, I had to rely maybe on graphically a little bit, but then we really need to understand what it means graphically in order for us to completely understand and move quickly through the examples and through the problems that we receive, and so that we're not wasting a lot of time with doing a lot of the algebra if we know actually what is actually going on graphically. Okay, all right, let's move on. Very good. So now we have a slightly different kind of a problem. And for the following exercises, it says graph the system of inequalities. All right then. Well, let's see. So the very first one is, I'm just going to try to simplify that a little bit. So I have x squared plus minus 2x, and then I have minus 4x. I'm going to add those together, minus 6x. And then I have plus y squared. I'm going to take the 4 and bring it to the left hand side as well. Okay, so that is negative 4 plus perhaps we don't need to do that. Let's retrace back. Let's just go back, and actually what we are going to do is, let's not do that. Let's just keep it. Let's just simplify on the left hand side, and then we'll see what happens. Okay, very good. So x squared plus 6x plus y squared. Clearly we can do that, and then I'm just going to write equal to 4 for now, just for the graphing purposes, and then we're going to shade it, etc. Whatever we need to do, we're going to reintroduce the inequality. Okay, all right, now when we have a situation like this, we want to complete the square in order for us to solve this and to graph it, and it's clearly a circle perhaps, because you have x squared minus 6 plus minus 6, and then you have a y squared term as well. So remember, in order to complete the square, so for a quadratic equation which is ax squared plus bx plus c, you take the b term, the coefficient of the middle term, and you divide it by 2 and you whole square it. Okay, and that is the term you want to add and subtract to complete the square. Okay, and we can discuss about the algebra of this, but let's go ahead and do that. X squared, so out here we have b term is negative 6, so divide by 2 whole squared, so that is negative 3 whole squared, which is 9. So I'm going to add a 9 and subtract a 9, minus 6x plus 9 minus 9, because remember that we have to add and subtract, also it's not going to make logical sense, plus y squared equals 4. Okay, good. So now I can take the first 3 terms and then write them as a perfect square trinomial, which is x squared minus 6x plus 9 can be rewritten as x minus 3 whole squared. So again, same thing, all I did was I took a squared minus 2ab plus b squared form, perfect square trinomial, wrote it as a minus b whole squared form. Okay, so x minus 3 whole squared. All right, and then I have a negative 9. I'm going to take that and maybe bring it over to the other side now. And then plus y squared. No, y squared has nothing else with it. So that's what it is. I mean, it's going to be 0, the y value perhaps of the center of the circle. And then 9 goes to the top, you get positive, so you get a 13 on the right hand side. Okay, very good. So now we can see when you go to your circle formula, remember the circle formula just right below here, x minus h squared plus y minus k squared equals r squared. So we can see what the circle formula is here and what the circle centers is h and k. So in this case, h and k is going to be, h is 3 and k is 0. So that's the x value, and y value is the center of the circle. Okay, and then what is the radius? Well, the radius is basically square root of 13, correct? Because square root of 13, when you square that, you're going to get r squared. Okay, so how much is that? 9, 3 3s are 9, 4 4s are 16, so approximately around 3.6 we would say. So radius is approximately 3.6. Radius is approximately 3.6 probably. And then what we're going to do, we just go ahead and draw our circle here then, and see we have room here. Okay, so we're going to go to 3, 0 and center our circle there. 1, 2, 3 on the x value and 0. That's the center of circle. Around 3.6. 3.6. I'm going to draw a radius. So this is all a little not that, a little rough. So also now I'm going to draw my circle with a dotted line, because you see you have an inequality and then we're going to shade it with. So I'm just going to go ahead and put the dotted line, because I don't want to put a solid line now, because I know that we have an inequality. Okay, so there we go. And so our final circle was, the equation was x minus 3 whole squared plus y squared is, now instead of the equality equal sign, I'm going to replace it with my less than sign, because that's what it was originally. So less than 13, which is 3.6, r squared is 3.6. So okay, so now at this point, our next one is, let's go ahead and do that. I'm going to use a different color for that. So our equation, our next one is y, let's set it equal to negative x plus 4, and then we'll add the inequality in just a minute. So if x is 0, y is 4. So if x is 0, we have y is 4. So that gives me approximately, here is a y-intercept. If x is 1, and then I get y is, if x is 1, then y is negative 1 plus 4 is 3. So 1 and 3. So approximately out here. So now I'm going to do another dotted line this way. Very good. So those are our two lines, and that's, pardon me, that's a dotted line, of course. Now let's do so if it were the circle, if it were more greater than 13, then it would be outside shading. But since it's less than 13, the shading of the circle is going to be inward. Okay, so it's going to be inward. The circle is going to be shaded inward. So let me just go ahead and do the circle shading first, this way, inward, not outside, because it's less than. And then of course the y is also less than negative x plus 4. So that shading is also going to be, when it's less than, it's going to be lower. When it's greater than, it's going to be higher. So that shading is also going to be this lower direction. So the point of intersection between the circle and the straight line, and I'm just going to use maybe a marker to show that, is this area right here. And that is our solution set. And looks like the 0, 0 is also included in that. If you wanted, you could go ahead and check a point just to make sure that your answer is correct. Always a good thing to do, not at all a bad thing, because that tells us if our answer is actually correct or not. So 0, 0, let's go ahead and check the point. Check a point within your answer. So let's just check 0, 0. Hopefully it's correct. So let's go ahead and substitute. So we received for the first one, for the first one, 0 squared minus 2 times 0 is 0, minus 0 plus 0. So all zeros on the left. Minus 4 times 0 is 0. So all zeros on the left is less than 4. So this is correct. 4 is greater than 0. That is correct. Next one, next equation, 0 is less than 0 plus 4. Again, 4 is greater than 0. So correct. So that point 0, 0 checks out for us, and it is correct. So this is our final answer set after graphing the system of inequalities. All right. Okay, very good. Let's move on. Okay, so solve the system of linear, nonlinear using substitution or elimination. So in this case, let's go ahead and multiply the first equation. You see there's a negative half and the second one has 2. So in order to make them equal, I don't even have to change the sign. I just have to multiply with a number. In this case, it turns out if you multiply the whole thing with 4, I should be able to match the second one. So let's go ahead and do that. 4 times negative half is times negative half x, and then 4 times negative 4y is negative 16y, and 4 times 4 is 16. And then that gives us 2 goes into 4 2 times, so negative 2x. So negative 2x minus 16y equals 16 is our first equation. I'm going to write the second equation below it like we did before. For in order to eliminate the one variable 2x plus 16y plus equals 2. So in this case, we're actually getting both variables are possibly getting eliminated, because so let's go ahead and add those. So that gives us 0 there, and that gives us a 0. 16y also gets cancelled. So on the left hand side only 0 remains. On the right hand side we have 16 plus 2 is 18. 0 is equal to 18. That is not true. So that is not true. So we have no solutions in this case. Again, no solutions. Okay, again, this is a case of parallel lines, so they are not going to coincide. And if you were to find the graphs of these and put them in y equals mx plus b form, you'll see that probably the slopes are the same. All right, let's move on and see what our next equation or what our next problem is. So we have y squared plus x squared equals 25, and we have so again, let's do this the graphical way, like we have done before. So let's take the first equation. So remember, x minus h squared plus y minus k squared equals r squared, generalized form of a circle. In this case, x, we can write this as x minus 0 squared plus y minus 0 squared equals 5 squared. So now you can see why 0 0 is the point. hk is the point of is the origin point in this formula. Okay, so you see why, because there are zeros. That's why this circle is centered at the 0. So let me go ahead and put my instant graph drawing skills to test here. Okay, so, all right, so again we center our circle at 0, and then our radius is 5 squared. So let me just go ahead and quickly do that. Okay, so approximately that would give us let me see if I am able to draw this circle. All right, not so great, but hope you bear with me here. All right, there we go. That's our circle. Okay, very good. So the next one, let's see. So we have y squared minus 2x squared equals 1. Okay. All right, so we are going to write this. And okay, so we have y squared minus 2x squared equals 1. That does not look like a circle because the coefficients are different and there's a negative between them. So that's probably most likely a hyperbolic equation. But before we discuss that, perhaps we can try to solve this a slightly different way. So let's backtrack a little bit and let us see if we can actually get the solutions without having to graphically make it more complicated. So I'm just going to erase my circle here, and then so I'm going to erase this part of my circle, and then let's go ahead and start this again. Hopefully we'll be able to get a solution of this. Okay, all right, so let's take the second equation. Let's start from there. So we have y squared minus 2x squared equals 1. I'm going to bring the 2x squared to the other side, and then we have y squared equals 2x squared plus 1, and then y equals square root of plus minus square root of 2x squared plus 1. Okay, very good. So I'm just going to go ahead and substitute that into the first equation. So we have y squared, which is plus minus. So whether we do plus or whether we do minus, it doesn't matter. It's all going to be positive because they're going to be negatives will multiply to give a positive answer. So when you multiply this, so if you have square root of 2x squared plus 1 plus or minus, and you whole square that, that's only going to give you back 2x squared plus 1 plus x squared equals 25. So that is coming together nicely. So let's go ahead and square that, and then now we have 2x squared plus 1. When you square that, the square root is gone, plus x squared equals 25. So let's go ahead and try to simplify that further by combining the like terms. That's 3x squared plus 1 equals 25. Okay, very good. And then we have take the x to 1 to the other side. So we have 3x squared equals 24. So divide both sides by 3 when we after that. So we divide both sides by 3, and then we'll get x squared equals 24 divided by 3 is 8. Okay, very good. So let's move on. Then we square root both sides, so plus minus square root of 8. So that gives us x equals plus minus square 2 root 2. So 8 can be written as 2 times 2 times 2. So that is square root of 2 times 2 times 2. So 4 can be brought out of the root. So that becomes square root of 4 is 2. So 2 root 2 is root 8. Okay, so x value has now two values, plus minus 2 root 2. Okay, so let's go ahead and substitute that x value that we have received into the first equation and see, because we essentially what we did was we took the we took the y value from the second and we substituted that into the first to get an x value is what we did. Okay, so now we have an x value, so now we can substitute that into either of those equations and get the y value, and then get ordered pairs from there. Okay, so let's go ahead and substitute that into the first equation and see what happens. Okay, so y squared plus x squared is now 2 root 2. Again, it's plus minus, but doesn't matter because you're going to square it, so the negative will become positive. So we are going to get 2 root 2 whole squared is, let's just write that, plus minus 2 root 2 whole squared equals 25. So that is again 8. So 8, so y squared plus 8, always going to be positive, equals 25. So bring the 8 to the other side. So that becomes, that gives us y squared equals 25 minus 8. Okay, so how much is that? So that is 17. Okay, very good. So now we can get the value of y, square root both sides, and of course plus minus that becomes, so that becomes y equals plus minus square root of 17. So those are the two x and y values we have received. So let's just write them down. X is plus minus 2 root 2 and y is plus minus root 17. So there are 4 answers here, and let's see what the answers are. So the answers are, just write down the x and y values as ordered pairs. X is, start with a positive or start with a negative, minus 2 root 2 and then minus root 17, and then that's the first one, and then minus 2 root 2 positive 17 square root of 17, and then the third answer is positive 2 root 2 negative root 17, and then positive 2 root 2 as the x value, and then positive 17. Okay, so these are the 4 answers. And then if you were to actually graphically solve this, you can go ahead and try this in your graphing calculator or in Desmos, and then you see the hyperbolas, they will coincide at 4 points because you have a circle, and then you have the hyperbolic equation. So you'll have 4 answers, and then it's difficult to receive those answers by graphically. I mean, you'd have to go and click on that point and find it through your graphing calculator and so on and so forth. But algebraically, this would be the way to solve it. Okay. All right. If you have any questions again about this problem, please let me know in the comments below. Let's see if we are done with our problem set here. Looks like we have another problem, so let's go ahead and see what we can do with this one. X squared plus y squared is greater than 4. So let's go ahead and this one I'm gonna maybe try to solve it graphically and see, because it seems like a circle and a parabola. So as we have done with the previous examples, I'm just going to go and draw my x and y coordinate planes here. X squared plus y squared. Let's set it equal to 4 so that I can actually solve it. X squared plus y squared equals 4, and then we'll deal with the inequality, the greater than sign. So remember, we said when there is no h and k value, the circle is centered at the origin. So again, the rationale behind it is x minus h squared plus y minus k squared equals 2 squared. 2 is the radius, and h and k here are 0 because there is nothing with the x. So it's going to be x minus 0 squared plus y minus 0 squared is 2 squared. So that means the circle is centered at the origin. Okay, and then the radius is 2. So let's go ahead and do that real quick here. Do a circle that shows us that circle. Now I'm going to draw a dotted line here because we have a greater than sign, so I don't want to put a solid line here for my circle. Okay, so let's go ahead and do that. All right, very good. So this is greater than, so this shading is going to be outside, okay, outward, but we'll wait on that for just a minute. Let's go ahead and do our second equation. This line is creating a little problem for us. Okay, let's go ahead and redraw this. Okay, good. All right, so our next equation is, let's set it equal first. Y equals x squared plus 1. Okay, so that, and then we'll deal with the inequality. So that means this is a parabola that has shifted up 1 unit. So 1 unit is right here, and then I'm going to do a dotted line again. So dotted line, so the parabola is just the parent y equals x squared parabola that has shifted 1 unit upward. Okay, like that. All right, now let's talk about shading. So this one is less than x squared plus 1. So the y is less than x squared plus 1. So always less than is lower shading on the lower side. So this shading is going to go this way. Correct? So lower shading like that. And then the circle happens to be shaded upward, right? Because the circle was x squared plus y squared is greater than 4. That is the equation of the circle. So not less than, so it's going to be greater than 4. So that shading, so we are trying to find the place where they coincide. Okay, because the system of equations or system of inequalities. So they coincides right here, right? So if you do an outside shading, it's going to coincide right there. So, well, that's wonderful. Because the coinciding point is with the circle and the parabola. So in order to actually, so it's a little more clear to you, I'm going to try to use this. So this was shading downward this way, and then the circle was outward. So circle is this way. So this is the commonality that we are shading here now, and that's all we can shade, and that's our answer for this solution set for this inequality. And of course we can also go ahead and verify this with using a single point of some sort. Like, I mean, if you use 0 0, which is clearly not in the answer for both of those, then you should not get correct. So if I go ahead and substitute 0 and 0, 0 is not greater than 4, so the 0 0 point fails. 0 0 point is fails our test. So let's find a point then that might be successful. So I'm going to find a point that is beyond the circle and into the this highlighted yellow that we have put over here. So and do 3 0, because 3 0 seems like it should be so it should be beyond, should be approximately in this out here perhaps. So I'm going to find that point. Okay, so find the point 3 0, which is approximately going to be around here. So that point should be within our shading region. So let's go ahead and use the 3.30 test point 30. So let's go ahead. First equation is x squared plus y squared is greater than 4. So substitute 3 squared is 9 plus 0 squared is 0 is greater than 4. That is correct. So for the second one, we have 0 is less than 3 squared is 9 plus 1, that's 10. So 10 is greater than 0. That is also correct. So our test point actually holds true. So our answer then is the solution that we have shown shaded in the yellow part here. That is our final solution. Okay. All right. Very good. So let's see if we are done with our problem set, or if we have any more problems to solve for today. Looks like I don't have any more problems to solve here today. All right, so basically I hope this was a lot of problems for us to solve today. And at any point whenever you see a problem set, just before I solve the problems, if you want to stop the video and go ahead and try to solve the problems yourself. I should have said this before the video, I guess. But anyway, if you have any questions, please leave them in the comments below. If you like this channel, then I would appreciate it if you give it a like and also subscribe to this channel. Also, please let me know what kind of content you'd like to see with respect to math, and also with respect to science, what kind of videos you would like to see over here. And then I appreciate it that you watched this video, and I hope you have a wonderful day, and I will talk to you in the next video. All right, have a great day. Bye bye.